Om Swastiastu. Good. Hello, Miss Rafita and Professor Sudiarto. My name is Putu Sellina Putri with student ID number 21130111083. For this course English Format 1, I am from 4D Mathematics Education. So I will create a learning videos for the final test that include how I open the lesson, how I explain math topics in this video is series and sequence, and how do you close the lesson, how do I close the lesson. So let's get started. Good morning, class. What a lovely day to start and learn mathematics, isn't it? Okay, how are things with you guys? Good? That's nice. So my name is Miss Sellina and I'll be teaching you math this year. So before we start today's lesson, I'll take attendance first. Who isn't here today? Karina. What's wrong with her? Oh, she's sick. She got a no for her excuse today? Oh yeah, right there. I see it. Okay, anyone else isn't here today? No? Okay, thank you everyone. So I will tell you that if you need to go to the bathroom or you need me to repeat what I'm just saying, etc. You need to go to turn off your camera. You can raise your hand and say what is on your mind, because we need a good environmental class, right? And we can make a lot of noise here. So let's begin today's lesson. Please take out your book and pencil and put your microphone on mute. So we learn about sequence and series. So we will learn about the sequence and series. And we will talk about sequences, we will talk about series, we will talk about word problems about sequence and series, of course. So math sequence. A sequence is a set of numbers in which the numbers have a prescribed order. Some common examples of sequence are arithmetic sequences, where the difference between successive terms is constant, and geometric sequences, where the ratio between successive terms is constant. In short, a sequence is a list of items or objects which have been arranged in a sequential way. The first one about arithmetic sequence. So arithmetic sequence is a sequence in which every term is created by adding or subtracting a definite number to the preceding number. So the formula is an equal to a plus n minus 1 multiplied by d, with an is the nth term, a is the first term, d the common difference, n is the number of terms. So the formula to find d in arithmetic sequence is successive terms minus preceding term. So far, any question? No? Okay, we will continue the example about arithmetic sequence. So the example of arithmetic sequence, I have a sequence like 2, 4, 6, 8, 10, and blah blah blah. So we can tell the a or the first term is equal to 2, and we need to find the d or the difference in this sequence, which eliminated the successive term with preceding term. Or we can say that d equals to an minus an minus 1. So in this case, I eliminate the second term with the first term, which means 4 minus 2 equal to 2. So d or the difference is equal to 2. So the formula for this sequence is an equal to 2 plus n minus 1 multiplied by 2. So in sequence, Besides we learn about arithmetic sequence, we also learn about geometric sequence. So a geometric sequence is a sequence in which every number in the sequence is equal to the previous number in the sequence multiplied by another constant number. And the nth term formula of geometric sequence whose first term is a1 and whose ratio is r is an equal to a1 multiplied by r to the power n minus 1, where n more than equal to 1. And let's move on to the example of geometric sequence. So the question is, find the sixth term of the geometric sequence for which a1 equal to 2 and r equal to minus 3. So the solution here is we need to substitute the values for n equal to 6 because we need to find the sixth term. So the n is 6 and r is equal to minus 3 because we know that in the equation r equal to minus 3. So the formula is an equal to a1 multiplied by r to the power n minus 1, along with the a1 is 2, or the first term is 2. So we substitute all of them to the formula and we get that the a6 or the sixth term is equal to minus 486. So far, do you get it, guys, or any question? No? Okay, you guys are so smart. And enough about sequence. We will move on to the series. So, a series is the indicated sum of a sequence of numbers. Examples of series are as follows: 1 plus 2 plus 5 plus 7 plus 9 plus 11, and example number 2 is 2 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64, and etc. So the first two series and the PowerPoint is the examples of arithmetic series, and the last two series are examples of geometric series. Why is it arithmetic series and geometric series? What's the point of arithmetic series and the geometric series? We will learn next. So in arithmetic series, there's a point we need to know, such as the order of the elements is not necessary. And series is a sum of elements that follow a pattern, so there's a pattern in series. The order of appearance is not important. So for the example of arithmetic series is 10 plus 15 plus 20 plus 25 plus 30 plus 35 plus blah 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 until un, or we can say it an as the previous slide. And the sum of arithmetic series, the formula is we called Sn equal to n divided by 2 multiplied by 2a plus n minus 1 multiplied d. So there is also geometric series. In geometric series, the order of the element also not necessary. So series is a sum of elements that follow a pattern. The order of appearance is not important. And in geometric series, the common difference known as a common ratio. The formula to find the ratio is successive term divided by preceding term equal to r. We call it the common ratio is r equal to a r to the power n minus 1 divided by a r to the power n minus 2. For example, about geometric series, 100 plus 50 plus 25 plus 12.5 plus 6.225 plus 3.125 plus blah 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 until un, or an. And in geometric series, there's a special case in geometric series. And the sum of geometric series divided by finite series and infinite series. There is also infinite and finite series and arithmetic series, but the sum of them is equal or the same formula you can use. But in geometric series, we use different formula because there's a different formula we use in geometric series. So for finite series, the formula we use is Sn equal to a multiplied by 1 minus r to the power n divided by 1 minus r if r less than 1. That's a finite series. And for infinite series, for if they are more than 1, the formula of the sum of geometric series is Sn equal to a times or multiplied by r to the power n minus 1 divided by r minus 1. So that's the formula about geometric series. So far, you can get it, guys? Do you get it? Or any question, or you need me to repeat something? Fine. Okay, let's move on to the example. The example is the word problem or the application about the sequence and series. So this is the question. Counting your 2 parents, 4 grandparents, 8 great-grandparents, etc. So how many direct ancestors would you have if you could trace your family back for 10 generations? We need to trace your family back for 10 generations. How we could do that? With geometric series. So the first thing is we determine whether the situation represents an arithmetic sequence, geometric sequence, arithmetic series, or geometric series. So the sequence are 2 because we have 2 parents, 4 grandparents, so the next sequence is 4, 8 grandparents, the next sequence is 8, and until 10 sequences. Represents a geometric sequence. Since you want the total of your direct ancestor, use the formula for geometric series. So we already know about what formula we use about this word problem. And the second thing is we need to identify the variables who is a, who is r, who is n, who is -1, and etc. Right? So a, or the first term, is equal to 2 because we're counting your 2 parents first, and the r, or the ratio, is 2 because the second term is 4 and the first term is 2. We divided them and we get 2 as the ratio, and the nth term is 10 because we need to find the 10th generation about your ancestors, right? So we substitute it and evaluate. To formula Sn equal to a multiplied by 1 minus r to the power n divided by 1 minus r. Why we use the finite series formula? Because the r is more than 1, right? The r is 2, so it's a finite series. So we substitute it, we evaluate, we calculated, and we got the S10 is equal to 2046. So going back 10 generations, you would have a 2046 direct ancestors. Yeah, that's about the material now, guys. How is it? Did you get it so far, or any question? No? You're good? Okay. So because we've run out of time, let's stop the lesson now because the lesson is already enough too. And one more thing before you go, next class you will learn about the quadratic sequences and make sure to prepare it before the class start because I will give you a little quiz for next class before the class start, of course. And don't forget to do your homework. Goodbye everyone and see you again next Wednesday. Thank you.